Saxon Algebra 2, Lesson 86. We haven't talked about graphing on a number line in a while. Let's dig in and take a look at that. I believe you're quite familiar with some of the basics of this, so let's just review. Graph. X is less than 3. The domain equals the positive, I'm going to have to squish, positive integers. All right, we draw a number line. We only add in what we need to add in. We don't have to go crazy with details. We need to get values of x less than 3. Okay, so I better put a 3 on here. Now, before I think about my answer, I know that I can draw a circle and draw an arrow. That will include all the little fractions and decimals in between the numbers. Or I can do the polka dots that just hit each number and don't include the fractions or decimals. Integers are what require the dots, right? Yeah. And this domain is limited to just positive integers. Okay, so let's give us some choices in here. Okay, x is less than 3. It does not include 3. Since I'm only putting dots on numbers, that means I have to skip 3 altogether. And I can only put it on positive integers. Okay, so 2 is a positive integer. 1's a positive integer. What about 0? Is 0 a positive integer? 0 is an integer, but it's neither positive nor negative. So no dot for little Mr. 0. So when we hear the word integers, in terms of graphing, we think dots. When we hear the real numbers, I'm just going to call them the reals, we think of the arrows. Okay? Those are the two different ways that we can reflect the domain. John sometimes likes to play this game of saying, okay, only positive integers. Okay, only negative integers. So we just have to think carefully. Let's do another one to get our brains back in gear around these. Graph, x is greater than minus 3. Domain equals the reals. Okay? Numbered line. I'm going to put in negative 3. It's the reals. Okay, that means it's an arrow. And I either circle it or solid a dot, depending on this. This is greater than only. So that means I don't want to color in the circle because I don't want to include negative 3 in my solution. It's the reals, so it's an arrow, and I go like this. Beautiful. This is the right answer, and this is the right answer. Okay? Remember with when we're graphing the integers, it's kind of unsatisfying because there's no way, well in this case we wouldn't want to. This is the only pair of numbers. But it's hard to show whether the numbers keep going or not. Most students find that kind of dissatisfying. The reals are more satisfying in that way. But in this case, we don't want the dots to keep going because it's only those two. Those are the only numbers that satisfy this. This one, it goes to infinity and beyond. So that's happy news. Okay, so there's a quick review on how we graph on a number line with inequalities. Now, I have something to introduce to you that sounds really, really hard, but trust me, it's so easy. Trichotomy axiom. Oh my gosh, both of those words seem so hard, but this is such a simple 3-part idea. I'm going to write it out and then we'll look at it. If it seems stupidly easy, don't feel bad. okay? For any two numbers, we're gonna just call them A and B for these purposes. Exactly one fact or one statement, which is a longer word, is true. Either A is greater than B, A is equal to B, or A is less than B. Only one can be true. All right? Sometimes we kind of combine these statements, but you'll see how this is helpful. All right? I hope you agree with me that that's pretty straightforward. Okay? So what happens if we're asked to graph something like this? I'm going to use a little abbreviation in my domain, negative integers. Okay, what's this? Whoa, that's called a negated inequality. It's saying, it doesn't say x is less than or equal to minus 4. It says x is not less than or equal to minus 4. So what this means is that A is not equal to B. This one's not true, and this one's not true, right? Do you see how both of these are reflected in this sign? But John has drawn the line through both of them saying it's not true. That means that it has to be this one. X must be greater than minus 4. If it can't be less than and it can't be equal to, then it has to be greater than minus 4. So now we have something we can graph. Whoops, I don't know why I put a line there. Ignore that. X is greater than minus 4, so I'm going to call this minus 4. And I'll go up from there. It's integers. It does not include minus 4 because we said no, we ruled that out. So that means it could be minus 3. That's a negative integer. Could be minus 2. Could be minus 1, and then we have to stop right here because we know that it can't be 0 because 0 is not negative. And I'm just going to write this here. As soon as we see the word integers in our domain, we know it's dots, not arrows. All right, so a negated inequality tells us if it's not those two, then it must be that one. There are 3 options to choose from, and the negated one tells us which one it's not. So then we have to consider, okay, so what's left? Example 86 point, are we all the way up to 4 already? Yeah. Am I out of the camera? A little, kind of falling away. Okay, graph. And I'm going to write up here, A can be greater than B, A can be equal to B, or A can be less than B. That is the trichotomy axiom, and it just gives us a list of the possibilities, right? So then we can do something like this. Minus x, I'm copying it from the book. The R stands for the real, so that tells us right off the bat that's arrow. Okay? This is a negated equality. It's not greater than. So if it's not greater than, then it could be less than, and it could be equal to. So when we have a negated inequality, we have to think of these 3 options and then choose the 2. Well, if the negated inequality represents only one choice, then we have 2 more to choose from. But as we saw in the other one, sometimes the negated inequality involves 2. Right here. So then we only have 1 left to choose from. So we're working from this list of 3, and we're looking to see what's been ruled out, and then we're writing the other possibilities. Fix that first, okay? And I'm gonna write that. Fix negated inequality first, before you play around with the algebra, because that's our next step, obviously, right? We've got a little bit of work to do here. So let's subtract 4 from both sides. Yes, let's do that. Then we'll have minus x is less than or equal to minus 2, right? Now we have to get rid of this minus 1. Okay, so in order to do that, we're gonna have to, let's multiply. We could multiply or divide. Whoa, this triggers things though. If we multiply or divide by a negative, we have to reverse the direction. And I wrote that carefully for a reason. Okay, we're multiplying by a minus 1 to get rid of this minus sign. But in doing so, we trigger a change in the direction. Now, notice that this change in direction has nothing to do with the trichotomy axiom. 2 different steps, and that's very confusing. Sometimes when students are here, they think, oh, when I flip this, then I'm negating the inequality, so I choose. No. When we multiply by the minus sign, all we do is pick up whatever's here and flip it over. We don't have to think about the trichotomy axiom. So that's confusing. 2 very different steps. This now becomes positive x, this flips, and this becomes positive 2. Crazy, right? So now we are ready to graph this. We're dealing with the reals. Oh, that's so easy. I love the reals. There's 2. We want to include it in the solution, so I'll color it in, and then we want everything greater than. That's our answer right there. Whew. This took a lot of work, right? 2 steps that are very different. The negated inequality, we have to think about the trichotomy axiom, and whatever's ruled out, whatever's not ruled out is what we use. And then when we have our minus multiplication or division, we just pick whatever's there up and turn it over. We don't worry about trichotomy. Okay, one more. Oh, there's 2 parts to this lesson. That slipped right by me. But, I mean, it slipped by me before, but luckily I'm just on my game now, so you get a bonus. 86.5, graph. Ready? Domain equals the negative integers. He's really into this positive negative thing. Okay, so this is dots. Sometimes I squiggle it, sometimes I put a bracket around it. I mean, style points awarded however you like. Okay, so the first thing we do is fix the negated, okay? So we remember either A is greater than B, A is equal to B, or A is less than B. That's our trichotomy axiom, and that's what we use to clear up our negated signs. If it's not greater than, and it's not equal to, then it can only be less than. So we'll rewrite this with a non-negated inequality, right? And then we do our algebra. And we get minus x is less than 2. And then remember, if we multiply, multiply, not add or subtract, my bad. Multiply or divide by a negative means we have to, what was the word I used? I like the way I said it back here. Reverse the direction of the sign, right? So we're going to multiply or divide. You can do it either way, whichever you prefer. I actually prefer to divide, but that's okay. This becomes positive x. It flips that, and that becomes minus 2. Okay, so that means x is greater than minus 2 is our final inequality. And we can only graph negative integers. So I start by putting in the number that's there. I want the values greater than negative 2, but I cannot include negative 2, and it's a dots only. So I can go negative 1, and I can go 0, and I can go 1, but I realize, oh, it's only negatives. So if I can't include minus 2, then that means my only answer is minus 1. Huh. Oh, I'm looking at the wrong problem. Sometimes I look at the answers and go, how did I get that wrong? But I didn't. I just looked at the wrong problem. Yay. Okay, cool. One more topic with just one problem, though I must say, it's a doozy. This is a step forward on those nonlinear systems of equation problems that we did. And remember, we went in the walk-in and we took the butter sculptures and we learned how to make the different shapes. And then we were combining them in systems of equations. And one thing we did was we took a circle, which is a nonlinear equation, and we combined it with a line. And we found that there are 2 points. Now, in the first problem that we did last lesson, I think one of the points was like 0 and minus 3. Remember, these are not necessarily accurate. And this was like 12 over 5 and 9 over 5. I think those were it. So they were fractions, but these are fairly simple numbers, right? They're rational numbers. Now, we're going to deal with a system of equations that looks just like this, but it's going to give us crazy answers. So here we go. And the really shame of all this is that when you first see the problems, you think, this looks adorable. This looks like a perfectly well-behaved problem. Look at how simple that is. Okay, what John doesn't tell you, but I will, is that this is the equation of the circle, and this is the equation of the line, right? We can tell by the squares and then the not squares. Okay, so we start out the same we did last time. We take the simpler equation, the line, and we get one of the variables by itself, and then we're going to square it to make it fit into here. So I'm going to take this one, and I'm going to rearrange it so x equals y plus 1, right? Swim that over. And then I would like to square both sides. Y squared equals. Now, you hopefully have enough experience with binomials that you can begin to square these in your head. If you need to write out x plus 1 times x plus 1, that's perfectly fine. X squared plus x plus 1. X squared plus 2x plus 1. If you need to write it out, that's absolutely fine. I'm not trying to shame you at all. What I am trying to say is that if you can see the pattern and do it without multiplying, please do. I know that the first one's going to be x squared. I know that this number is going to multiply to the ending term and it's going to add to the middle. So I can do it without having to do this handwork. Again, zero shame in the game if you need to write it out. But I do encourage you to practice trying to do these in your head. Okay, now we're ready to substitute this into this. It'll be all of this. Here we go. X squared, that's that one, plus, and I'm doing this just to help you see, x squared plus 2x plus 1 equals 9. Right? Beautiful. Now we are going to do some swimming, get everything on the left, see what we've got. 2x squared plus 2x, let's see, we didn't want to subtract the 9, minus 8 equals 0. Okay, that looks good. We can factor out a minus, or a positive 2. And we'll get x squared plus x minus 4 equals 0. Now we can discard this because we know 2 equals 0 is not going to yield us any solutions. I prefer to factor rather than divide, but at this point in the problem we can delete that because we're not trying to factor it, we're trying to find the solutions. So, how do we factor this? Are there two numbers that multiply to 2, or multiply to minus 4 and add to 1? No. So do you know what that means? Man-eating dragon. You're either sighing and saying, are you kidding me right now? Or you're like, yay for the man-eater. I couldn't be happier. Let's bring him out. I'm going to write him up here. X equals. Make sure you have this one locked down in your brain. Locked and loaded and ready to go. Minus 4ac all over 2a. That's our little guy. And now I'm going to fill in the blanks down here. Whoops, I went too soon. Minus b plus or minus the square root of b squared minus 4ac, that's a squared. Remember, you have to do it with buckets first or you will screw up the minus signs. Trust me, I'm just trying to save you trouble. A's are 1s, I put those in first. B is also a 1, and C is a minus 4. Just goes in one place. All right. What I like to do, I think I've mentioned this before, I like to simplify what's in the radical first before I rewrite it. 1 squared is 1 plus 4 times 1 times 4 is 16. So this equals 17. So x equals minus 1 plus the square root of 17. And I'm going to write these as separate fractions. They both have a denominator of 2. Okay. So I see what's happening here. John has given us two different values for x, which makes sense because we want two different values. But last time he gave us these cute numbers for x, and look what ungodliness he has unleashed upon us this time. They're irrational numbers. Whoa, irrational roots. Ew. So now what we have to do is we have to write these as two separate numbers, and then we have to use one of these equations to solve for y. Well, I propose we use this one because it looks the easiest, right? So what I'm going to do is I'm going to copy this to the top of the next page. I'm going to write these not as one. I'm going to break them apart and do minus 1/2 plus that, minus 1/2 minus that. I'll set them up in two columns, and then we'll use this to solve for the y's. Okay. So we had x equals minus, oh, it was minus 1/2 plus that, and then we had x equals minus 1/2 minus. Okay, so those are my two x values. I want to keep those straight and clear. Now I know that the equation, it was y equals x plus 1. And because of what I've got here, I'm going to change that 1 into 2/2 to make it a lot easier to simplify this. So I will write y equals this plus 2/2. Now, to solve this, these guys are going to become a positive 1/2, right? And then this stays the same. Make sense? And again, we could be working these with the denominators pushed together, but it's more precise and accurate to keep this and this separate, because this has the wacky root in it. That's why we do it. Okay, now I'm ready to try my other side. Oh, well, no, let's write out the point. Are you ready? No, I'm going to do it at the end because it will blow your mind and I don't want to ruin this. Now we do the same thing over here. Y equals x, which is minus 1/2 minus square root of 17/2 plus 2/2. Again, it was plus 1, but we converted. I'm going to draw a couple more lines so you can tell. We changed our 1 into a 2/2 because we knew our fractions were going to appreciate that. Minus 1/2 plus 2/2 gives us y equals positive 1/2 minus square root of 17/2. So I like how these guys are similar to each other. That feels good. These guys are very similar to each other. These guys are similar to each other. Now we have to write the final points. And I'm going to write them long so they go across. The first point is minus 1/2 plus square root of 17/2, comma, now here's the y value, positive 1/2 plus the square root of 17/2. That's one of the points where our line intersects our circle. Ready for the other one? There's our second x value. And here's the y value that goes with it. This is the answer to our problem. And if you don't feel like Albert Einstein Jr. at this point, I can't help you. That is so amazing that you figured that out. And as horrible and terrifying as these points look, you can take comfort in remembering that we have a circle, right? And it's balanced in the middle. Mine isn't perfect. That's why we're getting these points with these lovely matching sets of numbers, because it's probably going right through the origin, and that's why we're getting negative, positive, negative, positive. We're getting this weird combination of points. It's because it's very balanced and symmetrical, right? Last time, with this one, these were not balanced and symmetrical points. So even though these numbers are horrifying, I want you to appreciate the fact that clearly our circle is on the center and our line is coming through in some kind of really balanced ways. We're not learning how to graph circles yet, so you don't have to worry about that. It's actually pretty easy. But we're getting a nice symmetrical centered circle, and these points all mirror each other in some way that we're not going to worry about yet. So even though they're horrifying, there's a certain amount of order in our circle that we can love and appreciate. Well, I think we're done, don't you? That's plenty. We've worn ourselves out. Okay, the end. Bye.